ball A is projected vertically upwards at a velocity of 16 meters per second from the ground. Ignore the effects of air resistance. Use the ground as zero reference. Calculate the time taken by ball A to return to the ground. Right, you don't have a diagram there. Can you just try to make some sort of a diagram so that we understand what we have here? We're saying ball A is projected vertically upwards, okay? So there's ball A is projected vertically upwards. It's going up there. And at a velocity of 16 meters per second. 16 meters per second from the ground. So we say from the ground. Ignore the effects of air resistance. Use the ground as zero reference, meaning that that's where we are going to have our point of reference. All right. And what is the question? Calculate the time taken by ball A to return to the ground. You know, at other times this can have a problem because when you say to return to the ground, a person might think, okay, we've got this ball and then it's going up there, now it's returning. Are they talking about this part here? Or this is the ball that started here, it went up there, now it returned to the ground, whether this is what is asked. So basically, according to the question, this is actually what was asked. To hit the ground, to get back to the ground. So not there, but there. Okay, very important. Right, now I want you to be very careful of what I am going to put down here. Remember, we've got so many equations of motion. And what is important is always for you to check what you are given. According to the scenario here, what do we have? We have the initial velocity. It is not final. You are starting with that. That's your VI. And it has to go up to its maximum height where it cannot go further, but instead it is being pulled down. And at that moment, you will definitely be talking about VF, which is equal to 0. This is 16 meters per second. This is 0. And from there, you are always given that G, which is 9,8 meters per second squared. Okay. And this G is always acting downwards. Whether an object is going upward, whether an object is going downwards, G is always acting downwards. It is not depending on the way the object is going. No, it is always acting downwards. Very important. And when we are talking about this projectile motion, we always have to indicate direction when we solve problems with regard to this. Okay, right now let us calculate the time taken by the ball A to return to the ground. Now, which formula or equation can we use? Let's just check. Can we really use VF is equal to VI plus A delta T? Let's check if maybe that is enough. If I do that, do I have enough information? Yes, because at least I do put something about time because that's what I'm looking for, isn't it? Right, let's have a look at that. VF is equal to VI plus A delta T, right? And then VF, VI, A, and then delta T. Before we go anywhere, we've got, like, as I said, we've got to tell, let upward be positive. I think the arrow there, you can tell, or maybe you can't see up there. Let me just write it so that you are able to see. let upward be positive. That makes sense. Right, upward motion is taken to be positive. Okay, fine. Then if I choose VF is equal to VI plus A delta T. You know, this problem on its own can have 4 possible answers. You choose any that really can work for you, but go for a simple one with no complications, guys. For now, really, we cannot use the one with the delta S because I don't think you are given any information regarding, it's only about, velocity. So we cannot use that one with delta X or delta Y because you don't have that information. Eh? So let's stick to the one with enough information. Right. Substitution. That's where we have a problem sometimes. Look at what I'm doing. Minus 16 is equal to 16 plus. Remember this A, because you're talking about vertical motion, it will be substituted by the G when we put the values. All right. 9,8. Now I want to know, is this going to be positive or is it going to be negative? We said let upward be positive, which means this is going to be negative, guys. Be very careful. And then multiply it by what you are looking for. Right. Why negative 16? Remember, you have this object here. It goes up, it comes back. This is your VF. This is your VI. And here we said let this be positive. So this initial velocity, while it was going up with that velocity of 16, we put it as positive to show that it was going up. The object was going upward. And then this VF, it is still going to be 16 because there was no air resistance. There was nothing that really changed. And the position is still the same. It could have been different if the positions are not the same. But now the level there is the same. Now, what is it that we have there? We are going to have the VF as negative because it was reached while the object was now going downwards. And we know downwards is going to be negative. Be careful. Right, so I have taken the whole, movement, not only upward or only downward, but everything. It's easier that way so that you don't have to do many things or you're going to do one thing and then you'll get done with that. Right, let's have a look. Minus 16 is equal to 16 plus, not plus, but now we have a minus, isn't it? Minus 9,8 delta T, which means 9,8 delta T. You know, what I always prefer is to check whether whatever I have, whatever I am solving, the one that is unknown, when I put it to the left becomes positive, or when I put it to the right becomes positive. I choose that side where it will be positive so that I don't have a problem at the end where I will ultimately forget to change the signs. So I can see that here, the minute I leave it on the right-hand side, it will still be negative. Yes, it is true, this can go that other way and becomes negative, but it's not going to be a problem. But remember, it's going to be negative and a negative, and then from there, you've got to go another step further in order to multiply by -1 or divide by a negative answer on values so that you've got positive at the end. So preferably, it's always better to make sure that what you're looking for becomes positive before you even go to the answer. So check whether it will be positive when you have it on the left or when you leave it on the right, or either way. Okay, right, so we've got here this 16, this one, which is still on the right hand side, and then I bring that other one. It is no more going to be minus, isn't it? But you change the sign because it has changed the side. Sign goes with the side. So 16 plus 16, which is 32. So delta t will be 32 divided by 9,8. And if we have that, what are we going to have? We have there 32 divided by 9.8, and you have 3,27 seconds. That's another thing that is important. Make sure you always check what you have as your unit. Okay, so this is how you do that. So I will not confuse you with many methods, because you know the minute you do many of them, then you somehow tend to lose focus. So for now, let us stick to this one that I'm talking about. When you are talking about this projectile motion, try to stick to one round motion at a time. Don't take one from top to bottom and then from bottom to top or top to bottom again, you know, things like that. Take from bottom there, right round, and then to bottom again. And because they are of the same level, we know if there was no air resistance, velocity at the beginning or the initial velocity will be equal to the final velocity. And we know, yes, the time taken to go up will still be the same as the time taken to go down. So what I'm saying, what I was trying to avoid was to find the time for this only. Say we have V F is equal to VI plus A delta T for upward motion only. And let us still say this is positive, okay, upward motion. VF here, VF is not 16, it is 0. And then VI, yes, it is 16. And we said let upward be positive, so that will be it. Plus G is always downwards, minus 9,8 delta T. Right. Now we bring, I said to you 0 is equal to 16 minus 9,8 delta T. Preferably, let this negative be that other side so that you've got something positive already. Delta T is equal to 16. Fine. Delta T is equal to 16 over 9,8. What does that mean? Therefore, total time will be 2 multiplied by 16 over 9,8, which is still going to be 32 over 9,8. Y multiplied by 2 is time to go up multiplied by time to come down. We know time will be the same. So this answer and that answer will be the same. So why would you not have done that once and for all? So that is just another method. You can go for that other one. It is still fine. But make sure that what you always stick to will be your values, your signs. They are very important. So this is still going to be 3,27 seconds. This is not 5, guys. That is seconds. Okay.